guys, welcome back. Today we are on 11.6, similar triangles. Like I said at the beginning of yesterday, I have my notes front and back. I expect you to have notes when this video is done as well. So let's get started. Page 616. Alright, similar triangles. Similar triangles have the same shape, but not necessarily the same size. So they're both triangles, but one could be bigger or smaller than the other. There are two main tests for similarity. So to figure out if two triangles are similar, meaning same shape but different size, there are two ways to do it. Number one, if the angles of one triangle and the corresponding angles of a second triangle have equal measurements, then the triangles are similar. So if your two triangles have the same internal measures of angles, then they're similar. Test 2. If the measures of the sides of two triangles form equal ratios, which are called proportions, then the triangles are similar. So test 1 is to measure each inside angle, and if the inside angles of your two triangles are the same, they're similar. Test 2 is to measure the ratio of the side lengths of your two triangles. If all of the ratios reduce to the same fraction, then you have similar triangles. And then they just give you a quick example in your book of what that's talking about. So they give you triangle A, B, C, and then triangle D, E, and F. And so without drawing the two triangles, all that's saying is for our two rules to be correct. If these two triangles are similar, that means all of our angles have to be the same. Angle A has to be the same as its corresponding angle. Corresponding angle just means same relative position. So first angle and first angle. So angle A has to equal angle D. Angle B has to equal angle E. So angle B has to be equal to angle E. And last, angle C has to be equal to angle F. And that's just the first rule. Equal angles means similar triangles. The second one is the ratio of the side lengths. Remember, the placement of the letters matters, because when they just tell you triangle ABC, triangle DEF, the placement of the letters represents where the corresponding sides and angles are. So if we had triangle AB with side AB corresponds to DE. So angle AB has to correspond to DE. Side BC has to correspond to EF. And then AC has to correspond to DF. And each of these ratios has to produce the same fraction. If that's the case, you have corresponding triangles. Alright, and then your key concepts is basically just this. That when comparing two triangles, if your angles match, and remembering you're positioning in the sentence of the triangle ABC, triangle DEF, tells you where the relative positions are. So if your corresponding angles all match, you're good. If the ratio of your sides match, you're good. So let's look at example 1. Determine whether the pair of triangles is similar, then justify your answer. Justifying your answer just means show your work, explain what you did, other than just saying, yes, they're similar. How do you know? So give me 1 second to draw them up on the board. All right. So for example 1. We have a triangle that looks something like that. That's R, P, and Q. And then we have another triangle that looks something like that. That is an M, N, O. And then the only information about the two triangles they give us are some angles. They tell us angle R is 51 degrees. Angle Q is 51 degrees. Then they tell us angle M is 48 degrees. And then they have these two little arcs right here. And all that does is signify that whatever angle N is equal to angle O. So because they have the same arc, it means they're the same angle. So we know angle N is equal to angle O. We just don't know what those are. And so now we just kind of have to figure out a little more information about this triangle to be able to state that they're similar. We have two angles given here, we're missing one. We have one angle given here, we're missing two, but we know those two angles missing are the same. Because they haven't given us any sides, now means we're left with rule 1 or test 1 to test for similarity, which says every corresponding angle has to be equal, not just one, but every angle. And if all angles are equal, then we have similar triangles. So starting with our first triangle over here, it's really easy to find our missing value. P is our unknown value. And if we remember, all triangles add up to 180 degrees. So angle R, P, and Q all sum to 180. That means we can figure out what this is. So if the total of them all is equal to 180, then we have 51 plus 51 plus x is equal to 180. Your book does it a little bit differently. They state P is equal to 180 minus 51 plus 51, but I'm putting it in the way we normally solve these kind of problems. So 180 is equal to 102 plus x. Subtract 102 over. 78 degrees is equal to x. We know this angle is 78 degrees. So now we have our first set of corresponding angles. P and M, or angle P and angle M, are equal. So we're good to go. We know that that's great, but we still need to figure out about these two bottom angles. And just like we used an unknown value to be able to solve for our missing angles, we're going to do the same here. We know all three angles have to sum to 180. So 180 is equal to M, which is 78, plus N plus O. But we know N and O are the same, so we're going to let X equal N and X equal O, because we know X represents the same value in both cases. So plus X plus X. 180 is equal to 78 plus 2x. Subtract 78 to the other side, and we get 102 is equal to 2x. Divide out your 2, x is equal to 51 degrees. And since 51 represented, or not 51, x represented x and O, n and O, la 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 la. Since x represented n and x represented O, we know both interior angles are 51. And now we've proven that these two triangles are similar because every single internal angle matches the corresponding piece in the other triangle. Alright, moving on to example 2. Finding unknown measures. Proportions can be used to find the measures of a side of triangle when my dog is now here. Proportions can be used to find the measure of sides of similar triangles when some of the measures are known. So looking at example 2, A. Find the measures if each pair of triangles below is similar. So they're telling you to assume that the triangles are similar, and now solve for your unknown values. So we're going to write it up on the board, and again, this is example 2A. Alright, and they give us two triangles. They give us triangle TUV and tell us it's similar to triangle WXY. And now I'm going to go ahead and draw out my triangles. This is T, U, V, and then this is W, X, Y. TU is 3 units long. Did they tell us that? Yep. 3, 4, and 6. And then they have 2 unknown values on our other triangle. WX, they label as just A. That really means solve for it, we don't know what it is. WY, they label as B, so unknown value that they want you to solve for. And then the only numeric value they give you is XY, which is 16. And now if we're going to be forming a ratio, that means we're doing a comparison. And we're going to need to be drawn from this 16 to be able to solve for both A and B. So step 1 is we're going to be using our information to fill in our missing values. But we need to know which pieces correspond to which pieces of our second triangle. So we need to solve for WX. That's one of our unknown values. That's what we're solving for, WX. Well, what does WX correspond to? TU. But that's not enough. We need to come up with a second one so that we can do cross products. So we have our first set, but we need our second set. The only other information they give us that's viable that we can plug in is going to be XY because that's where our actual value is. So we're going to use XY. Well, what does XY correspond to? It corresponds to UV. So now let's take a second and actually plug in the information they gave us. So WX is just A, it's our unknown value. TU is the number 3. XY is 16. And then UV is 4. And because, again, we're assuming that these triangles are similar, that means the proportions are similar. So whatever this fraction reduces down to, this fraction has to reduce to. So what does A equal if it all has to reduce to the same thing? You can see, solve it with cross products. So we get 4A is equal to 3 times 16. 4A is equal to 48. Divide out 4 on both sides. A is equal to 12. So A is equal to 12. We're one step closer. Last value left to solve for is B. So I'm going to erase this just to create room on my board. And then we're going to go through the same steps again. We need to solve for B, which is WY. What does WY correspond to? It's our first and last value, so it corresponds to the first and last value over here. WY goes to TV. TV is here. And now again, we have to pull from the information they give us. They gave us WY, or XY, I'm sorry. XY corresponds to UV. And so now we plug in our information. WY is equal to B, or just the value we're solving for. TV is 6. XY is 16. UV is 4. So same for the last time. The reason we have these two fractions that equal to each other is we're assuming they're a proportion. Proportions mean they all reduce to the same thing. So what value do we have to plug in for B that when it reduces down to the smallest of 16 over 4? Use your cross products. For B is equal to 16 times 6. 4B is equal to 96. Divide out 4 onto both sides. B is equal to 24. And so we've solved for all unknown values, assuming that these two triangles were similar and being able to use their side lengths to form a proportion. All right, let's look at B now. So that was example 1A. Let's look at example 1B. Or example 2B, sorry. All right, they give us some wackadoodle looking triangle that looks like this. And they tell us the big triangle is A, C, D. And the smaller triangle is A, B, E. They tell us the height of the big triangle is X. The height of the small triangle is 10. The length is 6. And the length of this one is 9. Now before I solve this problem at all, because I think it's confusing like this, I'm going to separate my two triangles. I'm going to take my small triangle out of my big triangle. So I have my small triangle, which is A, B, E, that has a height of 10 and a length of 6. And then I have my bigger triangle here that had a height of X, which was unknown, and a length of 9, and it was A, D, C. And now I have my two triangles. I'm going to erase this top picture because I don't think it's very helpful, to be honest. And our goal is to use the sides to find our unknown value. Well, it's pretty easy to do here because they're only giving us the amount of information we need to solve. Our job is to solve for X. So CD is what we're solving for. CD corresponds to what? It corresponds to BE. Now we need to fill in the rest of it. So we had CD. Now we're going to compare our bases. So AD over this triangle's base, AE, and now we're just going to plug in the values we have. So CD is X. That's our unknown value. BE is 10. Then we have AD. AD is 9. AE is 6. And now we're going to do our cross products. We get 6x is equal to 90. Divide 6 onto both sides. X is equal to 15. So we've now solved for the height of this triangle using similar triangles in our rules about it. Alright, last example is example 3 on the next page, and it's a real life example. So it says, use similar triangles to solve a problem. Shadows. Janelle is standing near the Washington Monument in Washington, D.C. The shadow of the monument is 302.5 feet, and Janelle's shadow is 3 feet. If Janelle is she'd be tall. If Janelle is 5.5 feet tall, how tall is the monument? Step 1 for problems like these, always draw a picture because it's not worth the effort and potential of getting it wrong to do it in your head. So it is always better to draw a picture. So we have Janelle right here, having a great time. And then we have everyone's favorite, the Washington Monument. We're told that Janelle is 5.5 feet tall, and we're told that she's casting a shadow that is 3 feet. And then we're told that she's standing next to the Washington Monument, and we're solving for the height of it. We don't know the height of it, but we know that its shadow that is being projected down is 302.5 feet. And so now we're going to create a ratio with the information we have to solve for the information we don't have. Well, let's start with our shadows. We know Janelle's shadow is 3 feet, and we know the Washington Monument shadow is 302.5 feet. We know Janelle's height is 5.5 feet, and we don't know the Washington Monument's height. That's what we're solving for. So now we're going to use cross products to solve. And we get 3x is equal to 302.5 times 5.5, which is equal to 1,663.75. Then we're going to divide 3 out onto both sides, and we find out that x is equal to 554.6 feet. So we were able to use our cross products to be able to solve for the unknown value. So that's it for the practice problems. I'm going to do one from your homework just so that you have a good idea of what the wording means. So let's see. Your homework is going to be 4 through 24, but let's look at number 6. Number 6, so that we get an idea of what the instructions are asking. Because the instructions are going to be using the same 2 triangles for the next 4 problems. So 6 through 9, I'll go back to these 2 pictures of these triangles, but every time they're giving you new information. So you have 2 similar triangles. Off to the right of your page, triangle A, B, C. And then you have a smaller triangle right there. That's D, E, F. And these are all marked with capital letters. And then they're giving you these side lengths. So here, AB has a lowercase c next to it to represent its side length. BC has a lowercase a to represent its side length. And then AC has a lowercase b to represent its side length. And notice there isn't an actual side length given because each problem is going to change the side length. So then for DE, it's a lowercase f. EF is D. And then DF is E. Alright, so number 6 tells you C is equal to 15. I didn't do this one in my notes in case you can't tell. Alright. C is equal to 15. D is equal to 7. E is equal to 9. F is equal to 5. And your instructions say for each set of measures given, find the measures of missing sides. So they've given us 4 out of our 6. They gave us C, D, E, and F. That means we are missing A and B. These are the 2 sides we still have to solve for. So we have to draw on our information that they've given us to solve for our unknown values. So we're going to start with A. I'm going to start here. So I have lowercase a comes from the side BC, and BC corresponds to EF. And then I have to pull wherever I have information. They told me that C is equal to 15. They told me D is equal to 7. E is equal to 9. F is equal to 5. So BC is my missing value. That means on this triangle, the only information they give me is AB. So I'm going to pull AB as my second reference point. AB corresponds to DE. And now I'm going to fill in my missing values. BC with my little question mark by it is my unknown value. That's A. So I'm going to put in my A. EF is 7. AB is 15. DE is 5. And now I'm going to do cross products to solve. I get 5A is equal to 15 times 7, 15 times 7, 35, carry your 3, 3, 105. 105. Divide out 5 onto both sides. A is equal to 105 divided by 5, 2, 1. A is equal to 21. So now I've solved for my first missing value. A is equal to 21. But I'm not done. I still have to solve for B. Alright. So for B is measured from AC. What is my corresponding piece to AC? It's DF. DF measures as 9. I need to pull my information that I already have. I know that AB is 15. And then I'm going to pull back from over here again. I know DE is 5. I'm going to do cross products. And again, this is a 9. Not an A. 9. So I have 5B is equal to 15 times 9. 15 times 9, 5 times 9 is 45, drop your 5, carry your 4, 1 times 9 is 9, plus 4 is 13. So now I have 5B is equal to 135. 135 divided by 5, 2, 10, 3, 5, 7. B is equal to 27. So again, for these problems, all you do is copy down whatever information they give you and fill it into the small lowercase letters on your two triangles to know where your lengths go, because you're solving for an unknown value. So rather than telling you AB equals something, there's a little letter on the inside of AB, that's C. They tell you what that C equals, but that C is still just AB. Alright guys, good luck with your homework.